Right, then we have gone through analog to digital converter, how actually it is going to functioning, okay, and how it is going to convert analog phenomena into digital formats. So this was a basic operation which involves sampling process, quantization process, and coding process. Coding is actually the digital binary data. Okay, that is what a sampling, whereas we will be having the two signals here. One is original signal and another one is sampling frequency. Okay, whereas sampling frequency is greater than Fs should be greater than or equals to 2 Fm. Fm is the signal, uh, the original signal, analog signal. Okay. Then quantization, that is assigning a values, a numerical values to the samples collected by the sampling process. That is sample and hold circuit. Okay. And then coding. Coding is assigning a binary value for the quantized amplitudes, like here. So these are the quantized values for the quantization, the samples collected by this analog signal, and then for this the digital value, binary value is going to be allocated. So we require sampling and sample process, then quantization process, and then coding process to convert any analog signal into a digital format. So we were at this point in the previous class. Now the applications of analog to digital converter. Okay, so where all the places that we are using these devices or these converters, like a digital audio. Okay, Dolby speakers are there in all of your where laptops, or when you go for theaters or home theaters, right? Digital audio nowadays, digital audio, right? Then digital audio workstations. As I said, there are so many bars, sound system bars are there now. Bluetooth, um, Bluetooth devices, Bluetooth speakers. Okay. Then sound recordings. Sound recording in the mobile, I can record my sound, my voice, correct? Any music that can be recorded. And then pulse code modulation. That is in the communication process while transmitting the audio, the voice signals to some particular places or some other places, a pulse code modulation. And then digital signal processing. So where processors are used, like TV tuner cards, microcontrollers, even microcontroller require ADC, analog to digital conversion, because it doesn't understand analog signals. A TV tuner card doesn't understand analog signals. So there a digital signal is required. So TV tuner uses DSP processors. Then digital storage oscilloscopes, like a CRO is there in in the first semester you might have used in the laboratories. CRO analogs are there, but there are different oscilloscopes like digital storage oscilloscopes are present, right? And also it is used in such in scientific instruments like digital imaging systems. Like for an example, camera, right? Camera is a imaging system, correct? And that too digital. So digital imaging system. Okay, most probably you people are having a, what is that? Nikon DSLR 1500 15,000, 3,000 D, right? Canon, Canon is there. Uh, Wait a minute, just a minute. Okay, radar systems. Uh, okay, we were talking about a cameras, correct? Okay, cameras are a scientific or any type digital imaging systems, and then radar systems. Okay, obviously to uh, know the position of a moving object, a radar system is used in a military, right? In a navy, okay, or in a where we can say navy also, in all three types of army, okay, then in air force also, then temperature sensors, okay. So to find out a temperature which is present in the analog, we will not be knowing the digital value, okay. So to make it note in a digital or in a digits, we convert a temperature into a digital by using the temperature sensors, right? So these are the applications of analog to digital converter. Now, while explaining these applications, you should not just tell a digital imaging system, but instead you should tell what actually the digital imaging system. Say for an example of what is that called? Uh, in the medical system, we go for scanning, right? What is that scanning called? MRI. MRI scanning, correct? MRI scanning is also a digital imaging system. I'm not getting exactly what is the full form of MRI. Radio imaging or something is there. Okay, MRI scanning or so many scanning systems are there. So they are going to capture the image from our the physics, right? Physically. Then they are going to be represented into a picture. So that is what digital imaging systems. Then radar systems, as I said, Air Force or um, uh, military or navy system, navy. Okay, and then temperature sensors. This weather, all mobiles are having temperature sensors. Okay, then let us move on to the next another topic. The last topic of this module is digital to analog converter. Okay, similarly, when we convert any signal, any analog signal into a digital, what is the advantage is we can store the digital signal, first thing. The second thing is we can manipulate the digital signal, okay, by using a microcontroller or DSPs. And then we can represent it back. The stored data can be represented back to its original form. Now, when I want to represent it back, recover the digital data into its original data, then I require digital to analog converter. Correct. So how? So this is going to convert digital signals into analog format. Say for an example, it is being given up here. There are so many number of digits here, binary system. Parallelly, it is being given to digital to analog system, analog converter DAC, and the output of this circuit or this unit is going to be analog. Okay, and then a simple decoder method to convert digital to analog. Now there are so many methods are there. So many number of methods are there to convert digital form into analog method, analog format. Okay, out of that, here just an example is there. No need of example actually. We'll just list out. Pawan is speaking something. I'm not able to hear. Can you just write it into the chat box? Pawan, can you write the things into the chat box? If you people are having anything to say, type in the chat box. I'm not able to hear you here. Right? I don't have a speakers. That is why. Your voice is bit low. Okay, okay. Fine. Is it clear now? Okay, fine. So I'll continue. So here, digital to analog converter, where the digital input is being given to one unit, that is converter. Then that converter will convert this digital data into analog signal. Okay. Say for an example, I will be storing many of the MP3 songs. Okay. Then I cannot hear it directly from that row. So when I require some of the applications to play MP3, okay, MP3 player. So when I start that MP3 player, what that MP3 player is going to do? That MP3 player is going to use digital to analog converter. Okay. So what actually it will do? It will fetch the data which is stored into a digital form of that file. The file is being stored into a digital form, MP3 sound, and then it is being taken up, put into this hardware, and then that hardware is going to convert that software through that software. That hardware is going to convert the digital signals into analog, and then it is being given to that electrical signal is being given to speaker, whereas that speaker is uh, playing all that sound. Okay, this is what returning back. Okay, you people are having a speakers earphone, right? Whatever the things I am speaking here, that you are able to listen it. That is what digital to analog converter. Okay, so there are so many other methods are there. This is just an example where by using a decoder, the V reference. See, the thing is, we actually require reference voltage here. That is, whatever the digital signal that we are applying, A1, A2, A3, or B1, B2, B3, whatever the digital binary number we are giving as an input to the decoder. So this decoder, say suppose we have 3 bits here, 3-bit input. So how many combinations I will get? I will get 8 combinations. So for this 8 combinations, I require a different level of amplitude value. Okay, so for that purpose, what I will do, I will use reference voltage. So whenever any of this input has come here, 0 0 0, V reference will be 0 voltage. If it comes 0 0 1, then 0.125 0.125 volts will be the output. Then V reference, suppose if V reference is 5 volts, okay, 5 voltage divided by 8 values, 5 divided by 8, how much we will get? 5 divided by 8, type in the chat box. Um, 0.625. Okay, 0.625. Right. So one input will be having 0.625 value, and that is going to be in the incremented order, so that is why there are so many other types methods to convert this digital data into analog output. Okay, so for an example, as I said, so this is having 0.625, 0.625 volts. Suppose two inputs are applied at the same time, then what will be the output of this analog? 1.25 volts. If suppose three inputs are applied, then plus 0.625, then it will be around 1.85, 1.85 or 1.875 voltage. Then as I go on increasing the input, the output will be maximum of 5 volts, which is going to be converted into any other physical phenomena, okay, to analog phenomena. Okay, the output is voltage, and that is being given to some speakers, some of the displays, where those displays are going to display what actually the data is being given inside. Okay, so this is what the method of converting a digital data into analog value. Okay, now let us know, uh, take some applications. So as the digital audio, again, when it comes to an audio, what are the different types are there? CD has already been stored. It's an optical device, right? It has already been stored with some of the binary data, MP3 songs. It may be MP3 songs. It may be a video. It may be a films. So many, right? That is, or it may be a file also. Okay, that is going to be converted into analog signals. Okay, we hear it now. We watch some of the movies by inserting the CDs. Correct. Then I don't know what is MD. I think Blu-ray discs are there. Blu-ray discs are there. Then any one-bit audio. One-bit audio is what we have here. Let's say for an example, for one-bit audio. Okay, I'll check it and tell you. Okay, right. A digital audio. Then digital videos. So we have a DVDs, right? And digital still camera. Cameras are going to display, still in the cameras there will be a display in the left side, right? So that is going to display what actually the already stored data is there, right? Then the digital to analog conversion is used in communication equipments like a smartphones. Obviously, we have discussed that we have players, MP3 players or displays, many things. And then fax machines, right? Fax machine also going to generate digital, is going to convert digital to analog. That is, whenever the digital data is being transmitted over communication, that is being received at the fax machine, and it is being printed on the papers, fax machine. Then EDSI equipments. This one I'll check it. EDSL it is. ADSL means it's a modem, right? The modem also for the broadband, where the digital data is being transmitted, and after receiving it, it is going to be converted into analogs. Then PCs, personal computers, the video, audio, and video cards, audio and video cards which are installed in the personal computers. Okay, so that is what when we insert a video cards for our PC, we can connect the what is that cable disc cables, and we can watch certain channels in the display. Then measurement instruments, so programmable power supplies, and etc. Programmable power supplies, that is what we used to come to know how much power supply is being given up to certain particular circuit. Okay, so there we use analog to digital, or that is what digital to analog converters, right? So this is about analog to digital and digital to converters, and this is the end of the first module. Go through each and every point, every topic that we have discussed. If suppose if you don't understand, go for the videos that I have uploaded in the YouTube channel. Okay, for more content, if you don't understand the text from this uh, notes, you can refer the textbooks. It is quite lengthier, but quite good one also. Right. We'll end up the session. If you have doubts or things you want to say, tell me. You can write it in the chat box. Okay, fine. We'll close the session. Series of links, sir. Could you share series of links of your channel? Sure. No particular doubts, sir. Okay, fine, fine. No particular doubts. But you have hold out? Okay, not an issue. I already have shared it. Okay, fine. In the chat box only, I'll give you the link, my video, my YouTube channel link. See, Kadir, everything has been posted in the YouTube channel. Have you attended all the classes? Because that is important. Okay. So I have posted the playlist from my YouTube channel. You can go through that. Thank you.